yet again. Welcome back to GED On. On today's video, we're going to be covering part 2 of chapter 2, decimals and fractions. As you may remember, because chapter 2 is pretty long, we went ahead and split it into 2 videos. Therefore, it's really important that you watch part 1 before starting this video. Because GED On was created to follow along with the Kaplan book, it's really important that you have the book in front of you. If you do not have the book already, you can find links in the description box below on where to purchase it at your local store or online. Now, like always, you are more than welcome to pause and replay this video at any time. Make it work for your own learning style. Now, let's go ahead and finish up chapter 2. All right, everyone, like always, we will be continuing to utilize our Kaplan GED Test Prep Plus 2020 book for this and all GED On videos. You can find links below in the description box to buy this book either online or at your local store. Now, let's go ahead and get started on our first lesson. On today's video, we're going to be covering Unit 2, Mathematical Reasoning, Chapter 2, Decimal Fractions, Part 2. We will be covering lessons 4 through 7. Now, as a reminder, Chapter 2 is a long chapter, so please make sure that you watch Part 1 of Chapter 2 prior to starting this one. Now, let's go ahead and get started with Lesson 4. Starting on page 246. All right, so we're moving right along to Lesson 4, Fraction Operations. Okay, let's go ahead and start Lesson 4, Addition and Subtraction. Fractions can be added and subtracted if they have a common or same denominator. These are also called like fractions. So let's look at an example of this. So while you can see the entire process already written out, I am going to break it down by steps so that you know how we got to the next section. So for our first example, we are going to add 3 over 10 or 3/10 and 5 over 10 or 5/10. So for the first part, we are going to put this in an actual addition problem. Now, because they have the same denominator, we can just add across the board. So we have 3 plus 5 equals 8. And of course, we keep the same denominator, which gives us 10. While technically this answer is not incorrect, we can see that we can further reduce this, given that both 8 and 10 are easily divisible by the same number, which is 2. So we are going to divide both of these numbers by 2. 8 divided by 2 gives us 4, and 10 divided by 2 gives us 5. This is actually our final answer, which is 4/5. Now let's look at another example. We are going to subtract 2 over 9 from 7 over 9. So like before, even though this is not written in a column, we're going to put the biggest number on top or first. So that is going to give us 7 over 9 minus 2 over 9. This, of course, gives us 5 over 9. Now, this particular problem cannot be further reduced. Therefore, 5 over 9 is going to be our final answer. Okay, so because math can never just be easy, we have to learn how to subtract and add fractions that do not have the same denominator. If the denominators are not the same, one or both fractions will need to be raised to higher terms so that they may become like fractions. So let's look at our first example, which again is already broken out, but I want to go ahead and review how we got here. So our example is add 5 over 6 and 1 over 4. Now obviously we can see that they do not have the same denominator, so we're going to have to raise both fractions so that they can share a common denominator, and therefore we can just add their numerators across the board. So what is this going to have to entail? Well, we are going to have to find a multiple that they both share. Now, a multiple is a number that can be multiplied, or a result of a multiplication. So if we look at this, we see that multiples of 6 are 6, 12, 18. So what does that mean? Well, we can view it a different way. We know that 6 times 1 is 6, 6 times 2 is 12, and 6 times 3 is 18. Multiples of 4 include 4, 8, 12, and 16. So we can see that both 6 and 4 share a multiple of 12. So that is actually going to be our denominator. So what we mean by raising to higher terms is that if we change the denominator, we are going to have to do the exact same process that we did to turn the denominator into 12 with the numerator. So, in order to get from 6 to 12, we actually have to multiply 6 by 2. Therefore, we have to multiply the numerator by 2 as well. So 5 times 2 is 10. This gives us a rewritten fraction of 10 over 12. Moving on. In order to get from 4 to 12, we have to multiply 4 times 3, which means we're going to do the same with its numerator, giving us a final fraction of 3 over 12. Now that they share the common denominator, we can go ahead and just add the numerators. So we have 10 over 12 plus 3 over 12, giving us 13 over 12. Now we know that 13 over 12 is an improper fraction because 13 is larger than 12. So depending on what they may ask the answer to look like, this might be the final answer. But if they're asking you to take the improper fraction and to turn it into a mixed number, the actual answer is going to be 1, or the whole number, and 1 over 12. So again, you can do this by dividing 13 by 12. Let's look at another example. For subtraction, it states, subtract 4, 1 over 16, minus 1, 3 over 8. So we're going to have to find the same common multiple in order to do the same process. Now we know that 16 is actually a multiple of 8. So we can actually leave the 16 in the fraction 1 over 16. But in order for them to have a common denominator, we do have to change 3 over 8. So in this part of the process, you're actually just going to, not really regard those whole numbers, the 4 and the 1. Let's put those to the side. But what we're actually going to do is take 3 over 8 and multiply both the denominator and the numerator by 2. We know it's 2 because in order to get to 16, 8, or the denominator, has to get multiplied by 2. So therefore, we do the same with 3. This gives us a new fraction of 6 over 16. So now we have a new problem. We actually have 4, 1 and 16 minus 1, 3 over 8, which we actually know is going to now be 16 over 16 and 1 over 16. we are going to subtract the 1 from the 4, the whole numbers, which gives us 3. The fractions then leave us with 17 over 16. Therefore, the final answer is 3/17 over 16. Just kidding. So say they don't want the fraction to look like that. What you're actually going to have to do is continue to work through the problem. Now, we are going to take 3/17 over 16 and minus 1/6 over 16. So this will give us a final answer of 2/11 over 16. All right, everyone, let's go ahead and move on to practice 4.1, found on page 247. At this time, go ahead and pause the video and try to work through questions 1 through 4 of practice 4.1 on your own. Once you're ready to work through them together, go ahead and click play. Welcome back. Now that you've worked through these problems, let's go ahead and review them together. We'll start with practice question 1. We have 3/8 plus 1/8. So because these problems share the common denominator, we can just add across the board. 3 plus 1 equals 4, and of course we keep the same denominator. Now, this is not the final answer, given that this can be further reduced. Both 4 and 8 can be divided equally by 4, which gives us a final answer of 1/2. Question 2. 1/6 plus 5/6. This, of course, gives us 6/6. As I've mentioned before, if you have a fraction in which the whole number numerator and denominator are the same, it will always equal 1. Therefore, our final answer is also 1. Question 3. 8/9 minus 5/9. Again, they have the same denominator, so we're just going to subtract. 8 minus 5 gives us 3/9. This can get further reduced as both 3 and 9 are easily divisible by 3, giving us a final answer of 1/3. Final question, 7/12 minus 5/12. So we're just going to subtract across the board, which gives us 2/12. Further reduced, as both 2 and 12 can be easily divided or equally divided by 2, giving us a final answer of 1/6. At this time, go ahead and pause the video to complete practice questions section A and B of 4.2. Once you're ready to continue, go ahead and click play. So of course, we can't not speak about multiplication and division, as those are also operations of fractions. When multiplying and dividing fractions, it is not necessary to find a common denominator, which is super nice. So let's go ahead and work through some of these problems together. In our example, it states, what is the product of 7/8 and 1/2? So we know that the word product and of are both indicators of a multiplication problem. So let's break this down. What this is really stating is, what is 7 times 1 and 8 times 2? So we can actually rewrite this fraction to be a single fraction, but with two different operations, one in the numerator and one in the denominator. If we multiply this across, this is going to give us 7/16. Now, in this case, you can't further reduce this as there is not a single digit that equally divides into both 7 and 16. So this is in fact our final answer. Next example, what is 1 over 3 or 1/3 of 3 and 3/4? So in this particular case, because we do have a mixed number, we're actually going to want to start by turning it into a improper fraction in order to continue. So let's go ahead and put that 1/3 to the side for now. We're going to take 3 and 3/4 and turn it into an improper fraction. So as we've done in the past, what you're actually going to do is multiply the whole number 3 by the denominator, which gives you 12. You are then going to add 3, or the numerator, to it. That gives you a total of 15. Now remember that the denominator stays the same. So the new improper fraction is 15 over 4. Now that we have done that, we can multiply across the board with our original 1/3. So we're going to take 15 times 1 and 4 times 3. This gives us 15 over 12. But what if they actually want it in a mixed number form? So we're actually going to convert that. So its mixed form of a fraction from 15 over 12 is actually 1 and 3 over 12. Remember that you work backwards. So essentially what that's saying is 15 divided by 12. Now, this is not the final answer, as you can see that 3 over 12 needs to be further reduced. They can both be equally divided by the number 3. Therefore, the final answer is actually 1 and 1/4. Now, with multiplication and division, there is a shortcut that we can use. You can use a shortcut called canceling to reduce fractions as you work through the problem. Let's see this in our first example. We're going to multiply 1 and 1/2 by 1 and 1/5. So as you can see, both of these are mixed numbers. So what we actually want to do is to turn them into improper fractions. So if we were to take 1 and 1/2, we know that in order to turn it into an improper fraction, we're going to multiply the denominator by the whole number of 1. Then we are going to add the numerator. So 2 times 1 is 2, plus 1 is 3. We of course keep the same denominator, so that gives us 3 over 2. Let's do the same for 1 and 1/5. We take 5 times 1, which is 5, plus 1, which gives us 6 over 5. Now this makes it a whole lot easier. So what we're going to do is actually multiply 3 over 2 times 6 over 5. If we're multiplying from left to right, that gives us 18 over 10. Now, both of these numbers can be further reduced as they are both equally divisible by 2. Therefore, that gives us 9 over 5. But if we want to go back to its original form and turn this improper fraction into a mixed number, our actual final answer is going to be 1 and 4 over 5. Remember that you can do this by dividing 9 by 5. So like with multiplication, you can also use the shortcut called canceling to reduce fractions as you work through the problem. To divide fractions, 2 additional steps will be needed. Let's look at this through an example. Our example states, divide 8 by 1/2. So while I did write out the entire problem being solved, let's go ahead and discuss how we're going to get there. So as a first step, we're going to set up the division problem by writing the whole or mixed numbers as improper fractions. In this case, we only have one whole number and no improper fractions, the whole number being 8. So therefore, we're going to write 8 as a fraction. So this will turn it from just a whole number 8 into a fraction of 8 over 1. Therefore, 8 over 1 divided by 1 over 2. Now, one of those additional steps is to invert the fraction you are dividing by. The fraction that we're dividing by is, of course, 1 over 2. So what inverting means is that you're going to flip it so that the denominator is now the numerator and the numerator is now the denominator. Now the second additional step is to change the operation sign to multiplication. This now gives us 8 over 1 times 2 over 1. Because they now share the same common denominator, we can just use the regular rules of multiplication. So 8 times 2 is 16, and of course 1 by 1 is 1, but either way the fractions stay the same. This gives us 16 over 1, which in fact is actually just 16. That is our final answer. Now, as a side note, when you multiply by a fraction less than 1, the answer is smaller than the number you started with because you are finding a part of. When you divide by a fraction less than 1, the answer is greater than the number. So just a little side note to kind of keep in mind going forward. Now let's go ahead and move on to practice 4.2, found on page 249. At this time, go ahead and pause the video to complete questions 1 through 4 and 19 of section 4.2. For this first set of questions, you're going to want to solve, reduce answers to lowest terms, and then simplify improper fractions as mixed numbers. Once you have worked through these 4 problems on your own, go ahead and click play once you're ready to continue. All right, welcome back. Let's go ahead and start working through these problems, starting with problem 1. We have 2 over 3, or 2/3, times 1 over 4. Now we know that they don't have to have the same denominator, so we can just go ahead and multiply across the board. So if we have 2 times 1, that gives us 2, and 3 times 4, that gives us 12, we have 2 over 12. But we're not quite done because we can further reduce this, as both numbers are equally divisible by 2. This gives us a final answer of 1/6. Question 2. 5 over 6 times 1 over 2. Now, per our instructions, we were asked to change any mixed numbers into improper fractions before beginning. So let's go ahead and do that first. In this case, the mixed number would be 1 and 5 over 6. In order to do this, we are going to multiply the denominator 6 by the whole number of 1, which of course is 6. Then we're going to add 5. So 6 times 1 is 6. 6 plus 5 is 11. Remember that the denominator stays the same. So this gives us a new fraction of 11 over 6 times 1 over 2. Now we can follow the regular rules of multiplication. This gives us 11 over 12. This cannot be further reduced, therefore this is our final answer. Now we have 2 over 3 multiplied by 21. Again, we're going to want to change this into an improper fraction. Therefore, we're really going to have 2 over 3 times 21 over 1. That's our new improper fraction. Now we're going to multiply across the board. 21 times 2 is 42, and 3 times 1 is 3. This gives us a final answer of 14. It's 14 because 42 is easily divided by 3 14 times. So remember that fractions, again, are almost like division problems. And finally, last question. We have 50 times 3 over 8. So we're going to follow the same rules as in question 3. So we're going to do 50 over 1 times 3 over 8. Multiplied across the board, that gives us 150 over 8. Of course, we're not quite done yet, as that can be further reduced and then turned into a mixed number, giving us a final answer of 18 3/4. Okay, so for question 19, go ahead and work on this on your own by clicking pause. Once you're ready to review it together, go ahead and click play. But just to make sure that we have our instructions set, let's go ahead and read the problem first. A city is considering raising taxes to build a football stadium. A survey of registered voters yielded the following results. If 400 people were surveyed, how many would support the tax hike? All right, good luck everyone. We'll see you soon. Now that you have tried to do this problem on your own, let's go ahead and review it together. So what it's asking is, if 400 people were surveyed, how many of these people support the tax hike? So in this case, 400 is our total amount, which would also make it our whole number. Now we can see from our diagram that those that are for the tax hike make up 3/16 of the total. So let's go ahead and combine these particular numbers in order to solve the problem. So what this is really asking is, what is 400 times 3 over 16? As we saw before, we need to turn any whole number into an improper fraction so that we can just multiply across the board. This gives us 400 over 1 times 3 over 16. Now, 400 is actually easily divisible by 16, so we can further reduce these fractions. This gives us new fractions of 25 over 1 and 3 over 1. So what this means is that because 400 can be divided by 16 25 times, we can then replace 400 by 25. 16 is divided by 16 once. Therefore, 3 stays the same. So now we can just multiply across the board. If we have 25 times 3, that gives us 75. 75 over 1 is really just another way to say 75. Therefore, our final answer is actually B, 75. Now that we have worked through some of the practice questions together, go ahead and pause the video and complete practice questions A through B. Once you're ready to continue, go ahead and click play. All right, everyone, we are now to our third to last lesson, Lesson 5, Fraction and Decimal Equivalencies. Fractions and decimals can both be used to show part of a whole. Fractions can be changed into decimals by using division. So let's go ahead and take a peek at this. We'll start with example 1. Change 3 over 8, or 3/8, to a decimal. So remember when I said prior that fractions are really just like looking at a division problem, in the sense that you are going to divide the numerator by the denominator, which is exactly what we're going to do in this problem. So if we divide 3 by 8, that gives us an answer of 0.375. Now let's do the reverse. Change 0.35 to a fraction. Now this will take us back to our original lesson on the number line. We're going to write the decimal number over the place value name of the last decimal digit on the right. The last digit in this particular example is 5, which is also in the hundredths column. So that means that we're actually going to put this particular number over 100. Then, of course, we're always going to reduce to lowest terms if necessary. So, placing this over the last section, or the last place the decimal is, or the hundredths, gives us 35 over 100. Both 35 and 100 are easily reduced by dividing both numbers by 5. So if we take 35 divided by 5 and 100 divided by 5, that gives us a final answer of 7 over 20. Now, decimals and fractions can be really confusing at the beginning, but there are a certain couple things that can help you along the way. Memorizing equivalents, or the most common fraction and decimal equivalents, will assist you in solving percent problems. So what does that really mean? Well, that means that for every fraction, there is a decimal equivalent. Now, these, of course, are normal fractions, not anything crazy, but we do have a table for you to try and memorize, or at least memorize the most commonly used things in order to assist you. So you can see here that in each of these particular graphs, or these charts, we have decimals on the left and their equivalent fractions on the right. So this is kind of similar as thinking of, say, one single dollar. We know that 1/4 of that dollar gives us 25 cents. Therefore, the equivalent fraction of the decimal in this case of 0.25 would be 1/4. So it's kind of thinking about that in that fashion. Now, you'll also notice that the decimal equivalents for 1/3 and 2/3 are marked with a bar. There is a tiny bar over the last 3 and the last 6. What this bar indicates is that the decimal repeats indefinitely. So in the case of the bar over 3, that means that if we were to keep moving in that direction on the number line, it would just be nothing but 3s. The same would apply with the number 6, except that it would be endlessly a bunch of 6s. Now let's look at an example. Our example states, each dose of cough medicine contains 0.25 ounces of medication. How many ounces of medication are in 48 doses? So obviously we've already worked through the problem here, but let's talk about how we got here. So we have 0.25, and we want to know the amount of ounces in 48 doses. So really, again, this is a multiplication problem, and we know that because of the word of. So let's look at our fraction equivalent of 0.25, which we've already discussed, but taking it back to our table, we know that the fraction equivalent is 1/4. So that's going to be our first step. We're going to change 0.25 to a fraction of 1/4. Now, because it is a multiplication problem, of course, we're going to want to turn our whole number, or 48, into a fraction. Now, after a while, you will get used to not having to add the 1 underneath it, but we'll still pretend it's there. So really what we're looking at is 48 over 1 times 1 over 4. This gives us 48 over 4. If we were to reduce this, we know that 4 goes into 48 12 times. Therefore, this gives us a final answer of 12 ounces. Therefore, there are 12 ounces of medication in 48 doses. Let's look at another example. Ray inspects machine assemblies. He must inspect 12 assemblies during his 40-hour work week. On average, How many hours can he spend on each inspection? So this is a division problem in which you can actually use your calculator. Utilizing a calculator, we're going to divide 40 by 12. So we're going to plug in the number 40, press the division button, then input the number 12, and of course, enter or our equal sign. This will give us a final result of 3.33333. Or we can also look at this as 3.33 with a bar on top. So clearly this is just a big ongoing number. Because we know that 0.33 with a bar on top has a fraction equivalent of 1/3, we therefore know that the answer is going to be 3 1/3. So 3 1/3 hours. Now let's go ahead and do practice 5, which you can find on page 251. Now go ahead and pause the video and complete question number 1. We will be doing 3 questions in total, but of course, we will have you work through them on your own so that we can work with them together afterwards. Once you're ready to continue, go ahead and click play. All right, y'all, welcome back. Let's go ahead and work through this problem together. During a 25% off sale, store clerks find the amount of the discounts by multiplying the regular price by 0.25. What is the discount on an item with a regular price of $80? So what we're going to actually want to do is to turn this percentage into a decimal. Now, we're going to pretend that the 25% is over 100%, which it really is. Now, 25 over 100 indicates that the number, the decimal, goes to the hundredths place. Therefore, it's actually 0.25. Now, could you multiply $80 by 0.25 to get the same answer? Of course, but that makes it a little bit more complex. So to make it easier, we're going to want to then now turn this decimal into its fraction equivalent. So we know from our previous lesson that the fraction equivalent of 0.25 is 1/4. Now, it's asking us to find the of something, the regular price of $80 with a discount, which means that this is a multiplication problem. So like before, we're going to take 1/4 and multiply it by 80 over 1. This gives us 80 over 4, which then we can further reduce to 20. This means that the discount of that item is actually going to be $20 as our final answer. Like before, go ahead and try to work out problem 2 on your own. Once you're ready to review it together, go ahead and click play. Okay, so let's go ahead and read the problem. At Linton Products, 3/10 of the workers are in the company's rideshare program. If there are 480 workers, which of the following expressions could be used to find the number in the rideshare program? Like before, we know that this is a multiplication problem because of the word of. So like our previous example, we're going to use the equivalence table again to find our final answer. Luckily for us, we don't actually have to solve the problem, only select the proper way to set it up. We can see from the table that the equivalent of 3/10 in decimal form is actually 0.3. Therefore, Off bat, we can eliminate options A and B as possible answers, as we know the equivalent decimal is 0.3, not 0.7. This leaves us with options C and D. Now, given that we know it's a multiplication problem, the answer is actually pretty obvious. In this case, the correct answer would actually be C, 480 times 0.3. If you were to divide or to multiply that out, you would actually know how many of those workers participate in the rideshare program. So this one was a pretty simple example. Now, let's go ahead and move on to the third one. So of course we have the same process. Go ahead and pause the video and try to complete question 3 on your own. Once you're ready to review it together, go ahead and click play. So let's read the problem together. Sharon is using the calculator to find out how many hours she has spent on a certain job. She divides and her display reads as 4.6666 and so forth. Assuming her calculations are correct, how many hours did she spend on the job? So like before, we're going to want to take this decimal and make it into a fraction. So we have the 4.6666. Now, let's look at our decimal and fraction equivalent table. Let's go ahead and ignore this 4 in front of the decimal and just look at 0.666. We know that that particular decimal has a fraction equivalent of 2/3. Now, it's actually this easy. We can now bring back the 4 because that doesn't change. And we're going to change the 0.666 and so forth to its fraction equivalent of 2/3. Therefore, the final answer is B, 4 2/3 of hours. Now that we have completed questions 1 through 3 together, go ahead and pause the video to complete practice questions 4 through 6. Once you're ready to continue, go ahead and click play. All right, everyone, second to last lesson, lesson 6, decimals and fractions on the number line. Alrighty, lesson 6. As you may now know, a number line represents numbers in order from least to greatest. The arrows on the ends represent that the numbers continue forever in both directions. Therefore, a number line can include decimals and whole numbers. It can also represent fractions and mixed fractions. So a number line really kind of contains everything. Let's look at this example. John works 5 shifts per week. His boss asks him to spend exactly half of his time this week working on a specific project. How many work shifts will John devote to that project? It's asking us to circle the answer on a number line. So here's our number line example that they provide us. So we can see by our number line that it's actually divided up by halves, or 1/2. That's how it progresses. So you'll see 1, 1.5, 2, 2.5, and so forth. So the final number is 5. So essentially we can visually pick where the half point is, but we can also solve the problem together. So we're going to multiply 5 by 1/2 to determine that John will spend 2.5 hours, or I guess in this case, shifts, 2.5 shifts he is going to devote to a certain project. Therefore, our final answer is in fact 2.5 shifts. Now, Like I said, you can visually do this on the actual number line. However, I don't want you to be tricked because visually the immediate middle point or the focal point appears to be 3, but that's not the correct answer. Therefore, it is just best that you work through the problem on your own, just to make sure that you have the correct answer. Okie doke. Next up, we have practice 6. This can be found on page 253. Alrighty, so we are going to work through practice questions 1 through 2 of section A. But for now, go ahead and pause the video and try to work through them on your own. Once you're ready to review them together, go ahead and click play. Okie doke, first up we have question 1. What is the value of the point on the number line below? We have 4 options, excuse me. We have A, 0, B, 1/6, C, 2/3, or D, 1 1/3. So if we take a peek at our number line, like before, we can see that the numbers are increasing by a certain increment. In this case, it's actually by 1/3. So we go from 0 to 1/3 to our decimal point, or our value point, to 1 1/3. Therefore, we can go ahead and determine that that particular point of value lands on 2/3, as that would make the most sense moving forward. Now, if that's a little confusing, let's break it down. So we have, again, 0 to 1/3 to then 2/3, and then we have that 1. But remember that any number above itself in a fraction, or where the whole numbers match in the numerator and the denominator, that's always going to be equivalent to 1. So while it says 1 on here, what that really is also saying is 3/3. Therefore, again, our answer is C, 2/3. Next question. What is the value of the point on the number line below? So similarly, we can see that this number line is increasing by factors of 0.2. So we go from 2 to 2.2, 2.4, 2.6. Therefore, we can deduce that the net actual number where this value point is 2.8, which is our final answer. Now that we have done those first 2 problems together, go ahead and pause the video, complete practice questions 3 through 8, and click play when you're ready to move on. We are finally at our last lesson. Thank goodness, right? So lesson 7, decimal and fraction calculator skills. So as we mentioned in the first video, you will be allowed to use a calculator on the official GED test. This does not mean that you'll be allowed to use it for the whole test, but at least for certain parts that require it. Calculator decimal operations are performed in the same manner as operations with whole numbers, except that for this case, you will have to insert decimals, so you will need to utilize the point button, or the dot button, or the decimal button, whatever makes the most sense to you, which is located under the number 2 button in the white numeric pad. So we can see the decimal point key right here. You will utilize several calculator functions to work with both fractions and mixed fraction operations. Now, if you have a calculator at home, this would be a great time to kind of brush up on where the buttons are. If you don't have one at home, like I mentioned before, we will be providing links below to some online calculators that you can practice with. So to work through this program, we are going to want to use a calculator. For this example, it's asking us to reduce 56 over 448 to its lowest terms and then also convert it to a decimal. So at this time, let's go ahead and bring out our calculators, turn them on, and clear them so that there's nothing or a zero on the screen. We're then going to want to use our fraction key, which is the one that you will see that has the letter N in the numerator and D as the denominator. That should give you a little bit of a clue what that button is for. So we're going to press that fraction button to enter our fraction. We're going to enter 56 at the blinking cursor in the numerator. Then we're going to use the down cursor key, or that arrow down, to enter 448 in the denominator. If you do not push the down cursor, it will keep adding numbers into the numerator. So that part is super important. Now that you have your fraction in there, go ahead and press enter, or what I like to call the equals button, to reduce the fraction to its lowest term. It will appear on the right side of the screen as 1 over 8, or 1/8. To express the fraction as a decimal, you're going to then press the toggle button. So the toggle button has two little arrows, one pointing to the left and one pointing to the right. So it's almost kind of like a mini number line. Once you press that button, the final decimal will appear as 0.125. This then is going to be the answer to taking 56 over 448 to its lowest terms and then converting it to a decimal. Great job! Okay everyone, this is our last example. It reads, a plastic pipe is about to be cut into pieces measuring 1 7/8 feet. The original pipe was 20 5/8 feet long. How many pieces can be cut from the pipe? So this is another great example that you can use your calculator on. So again, go ahead and clear your calculator. What we're going to do first is click on a midst fraction. So the midst fraction button is going to be a green second function button over the original fraction button. So you can kind of tell these two apart because you'll notice that the midst fraction has like a little U in front of it. So that's ideally where the whole number would go. And of course the ND would be the regular fraction. You're going to press the insert second button key and the fraction key. Enter the number being divided first, which is 20 5/8. You're going to enter the 20, then follow the direction on the screen arrow and press the right arrow button to move to the fraction cursors. Next, you're going to enter 5 and then use the down arrow to enter the 8, just like our previous example. You're going to exit the fraction by pressing the right arrow again. So it's kind of almost like walking out of it, so to speak. At this point, you're going to press the division key. Follow the same process with the second number, which is 1 7/8. Starting with the second function midst number button, that little U, the N, and the D. Then you're going to press enter for the actual solution. In this case, the actual solution is going to be 11. So 11 pieces can be cut from the pipe. This is the number that you should also see on your calculator. Now, unlike previous lessons, we will not be working through the practice questions of practice 7 together. And now we won't be working through them because they will require a calculator. Therefore, these are problems that you can do on your own. Remember, you can find the answer to these questions in the back of the book. For these particular questions, you can find the answers and explanations beginning on page 664. Everyone, we made it through chapter 2. This was super long, but I'm super, super proud of you. Now, we want to keep it going, keep the momentum going. So for the next video, we're going to cover chapter 3, ratio, proportion, and percent. But remember, if you still need a little bit more practice, you're more than welcome to watch the video or go through your book before moving forward. We'll see you soon. Bye-bye.